Hello children, today we are going to learn Unit 15 Chemistry, Carbon and its compounds. Come, let's enter into this video session.
Hello children, today we are going to learn Unit 15 Carbon and its compounds. Carbon is one of the most important non-metallic elements. Antony Lavoisier named carbon from the Latin word carbo, meaning coal. This is because carbon is the main constituent of coal. Coal is a fossil fuel developed from prolonged decomposition of buried plants and animals. So, it is clear that all the life forms contain carbon. The Earth's crust contains only 0.032% of carbon, example 320 parts per million by weight, in the form of minerals like carbonates, coal, and petroleum, and the atmosphere has only 0.03% of carbon dioxide. Example 300 parts per million by weight. Even though available in small amount in nature, carbon compounds have an immense importance in everyday life. Carbon is present in our muscles, bones, organs, blood, and other components of living matter. A large number of things which we use in our daily life are made up of carbon compounds. So, without carbon, there is no possibility for the existence of plants and animals, including human. Thus, carbon chemistry is also called as living chemistry. So, in this lesson, we are going to study about the special features of carbon, its properties, and also about plastic, which are the catenated long chain compounds. Compounds of carbon classification. Carbon is found both in free state as well as combined state in nature. In the prehistoric period, Asians used to manufacture charcoal by burning organic materials. They used to obtain carbon compounds both from living things as well as non-living matter. Thus, in the early 19th century, Berzelius classified carbon compounds based on their source as follows. Organic carbon compounds. These are the compounds of carbon obtained from living organisms such as plants and animals. Example ethanol, cellulose, starch. Inorganic carbon compounds. These are the compounds containing carbon but obtained from non-living matter. Example calcium carbonate, carbon monoxide, carbon dioxide. Inorganic compounds of carbon. Formation, properties, and uses of some of these compounds are given in this table. Compounds, formation, properties, uses. Carbon monoxide, that is CO. Formation is not a natural component of air, mainly added to atmosphere due to incomplete combustion of fuels. Its properties: colorless, odorless, highly toxic, sparingly soluble in water. Uses: main component of water gas CO plus H2. It is a reducing agent. Carbon dioxide CO2 occurs in nature as free and combined forms. Combined form is found in minerals like limestone, magnesite, formed by complete combustion of carbon or coke. Its properties: colorless, odorless, tasteless, stable, highly soluble in water, takes part in photosynthesis. and its uses fire extinguisher, preservative for fruits, making bread, to manufacture urea, carbonate water, nitrogenous fertilizers, dry ice in refrigerator. Calcium carbide CaC2. Its formation prepared by heating calcium oxide and coke. Properties: grayish black solid. Uses: to manufacture graphite and hydrogen to prepare acetylene gas for welding. Carbon disulfide CS2. It's directly prepared from carbon and sulfur. It's colorless, inflammable, highly poisonous gas, and it uses solvent for sulfur to manufacture rayon, fungicide, insecticide. Next is calcium carbonate CaCO3, prepared by passing carbon dioxide into the solution of slaked lime. Its properties: crystalline solid, insoluble in water, and its uses is antacid. Sodium bicarbonate NaHCO3. It's formed by treating sodium hydroxide with carbonic acid H2CO3. Its properties: white crystalline substance, sparingly soluble in water, and its preparation of sodium carbonate, baking powder, antacid. Special features of carbon. The number of carbon compounds known at present is more than 5 million. Many newer carbon compounds are being isolated or prepared every day, even though the abundance of carbon is less. The number of carbon compounds alone is more than the number of compounds of all the elements taken together. Why is it that this property is seen in carbon and in no other elements? Because carbon has the following unique features. Catenation. Catenation is binding of an element to itself or with other elements through covalent bonds to form open chain or closed chain compounds. Carbon is the most common element which undergoes catenation and forms long chain compounds. Carbon atom links repeatedly to itself through covalent bond to form linear chain, branched chain, or ring structure. This property of carbon itself is the reason for the presence of large number of organic carbon compounds. So, organic chemistry essentially deals with catenated carbon compounds. For example, starch and cellulose contain chains of hundreds of carbon atoms. Even plastics we use in our daily life are macromolecules of catenated carbon compounds. Tetravalency. Another versatile nature of carbon is its tetravalency. The shell electronic configuration of carbon is 2, 4. Atomic number is 6. It has 4 electrons in its outermost orbit. According to octet rule, that is 8 rule, carbon requires 4 electrons to attain nearest noble gas, that is neon. So, electronic configuration of neon. So, carbon has the tendency to share its 4 electrons with other atoms to complete its octet. Octet means 8. This is called its tetravalency. Thus, carbon can form 4 covalent bonds with other elements. For example, in methane, carbon atom shares its 4 valency electrons with 4 hydrogen atoms to form 4 covalent bonds and hence tetravalent. Multiple bonds. As seen above, The tetravalent compound can form four covalent bonds. With this tetravalency, carbon is able to combine with other elements or with itself through single bond, double bond, and triple bond. As we know, the nature of bonding in a compound is the primary factor which determines the physical and chemical characteristics of compound. So, the ability of carbon to form multiple bonds is the main reason for the existence of various classes of carbon compounds. In this table shows one of such classes of compounds called hydrocarbons as the type of bonding in them. Type of bond: single bond, double bond, triple bond. Single bond: methane. Class of the compound: alkane. Double bond: ethane, alkene. Triple bond: ethine, alkyne. When one or more hydrogen in hydrocarbons is replaced by other elements like O, N, S, halogens, etc., a variety of compounds having different functional groups are produced, and you will study about them in your higher classes. Isomerism. Isomerism is another special feature of carbon compounds, especially found in catenated organic compounds. Let us consider the molecular formula of an organic compound C2H6O. Can you name the compound? You can't, because the molecular formula of an organic compound represents only the number of different atoms present in that compound. It does not tell about the way in which the atoms are arranged and hence its structure. Without knowing the structure, we cannot name it. A given molecular formula may lead to more than one arrangement of atoms. Such compounds are having different physical and chemical properties. This phenomena in which the same molecular formula may exhibit different structural arrangement is called isomerism. Compounds that have the same molecular formula but different structural formula are called isomerism. In Greek words, iso means equal, meros means parts. Let's see the illustration. The given formula C4H10 is having two kinds of arrangement of atoms as shown below: CH3, CH2, CH2, CH3. B, CH3, CH, CH3, CH3. Both the compounds have same molecular formula but different kind of arrangements. In compound A, the oxygen atom is attached to a hydrogen and a carbon. It is an alcohol. Whereas in compound B, the oxygen atom is attached to two carbon atoms and it is an ether. These compounds have different physical and chemical properties. You'll study about isomerism in detail in higher classes. Crystalline forms of carbon. Diamond. In diamond, each carbon atom shares its four valency electrons with four other carbon atoms, forming four covalent bonds. Here the atoms are arranged in repeated tetrahedral fashion, which leads to a three-dimensional structure, accounting for its hardness and rigidity. Graphite. In graphite, each carbon atom is bonded to three other carbon atoms through covalent bonds in the same plane. This arrangement forms hexagonal layers which are held together one over other by weak van der Waals force. Since the layers are held by weak forces, graphite is softer than diamond. Fullerene. The third crystalline allotrope of carbon is fullerene. The best known fullerene is Buckminster fullerene, which consists of 60 carbon atoms joined together in a series of 5 and 6 membered to form spherical molecule resembling a saucer ball. So its formula is C60. This allotrope was named as Buckminster Fullerene after the American architect Buckminster Fullerene because its structure reminded the framework of dome-shaped halls designed by Fuller for large international exhibitions. It is called by the pet name Buckyball. A large family of fullerenes exists, starting at C20 and reaching up to C540. Amorphous forms of carbon. In amorphous form of carbon, carbon atoms are arranged in random manner. These forms of carbon are obtained when wood is heated in the absence of air. Example, charcoal. Physical properties of carbon and its compounds. Carbon is a nonmetal found in various allotropic forms from soft powder to hard solid. All the allotropic forms of carbon are solids, whereas its compounds exist in solid, liquid, and gaseous state. Amorphous forms of carbon and graphite are almost black in color and opaque. Diamond is transparent and shiny. Chemical properties of carbon and its compounds. Elemental carbon undergoes no reaction at room temperature and limited number of reactions at elevated temperatures, but its compounds undergo large number of reactions even at room temperature. Oxidation reaction with oxygen. Carbon combines with oxygen to form its oxides like carbon monoxide (CO) and carbon dioxide (CO2). With evolution of heat, organic carbon compounds like hydrocarbon also undergo oxidation to form oxides, and steam with evolution of heat and flame. This is otherwise called combustion. Here, 2C plus O2 gives 2CO plus heat, and C plus O2 gives CO2 plus heat. CO is the carbon monoxide, CO2 is the carbon dioxide. CH4 plus 2O2 gives CO2 plus 2H2O plus heat. Reaction with steam. Carbon reacts with steam to form carbon monoxide and hydrogen. This mixture is called water gas. C is the carbon plus H2O water gives CO plus H2. Reaction with sulfur. With sulfur, carbon forms its disulfide at high temperature. C plus S gives CS2. Reaction with metals. At elevated temperatures, carbon reacts with some metals like iron, tungsten, titanium, etc. to form their carbides. Tungsten plus carbon gives tungsten carbide. Carbon compounds in everyday life. It is impossible to think of our daily life without carbon compounds. Over time, a large number of carbon compounds have been developed for the improvement of our lifestyle and comfort. They include carbon-based fuels, carbon nanomaterials, plastics, and carbon filters, carbon steel, etc. Even though carbon and its compounds are vital for modern life, some of its compounds like CO, cyanide, and certain types of plastics are harmful to humans. In the following segment, let us discuss the role of plastics in our daily life and how we can become aware of the toxic chemicals that some plastics contain. Plastics catenated long chain carbon compounds. Plastics are a major class of catenated organic carbon compounds. They are made from long chain organic compounds called polymer resins with chemical additives that give them different properties. Different kinds of polymers are used to make different types of plastics. Plastics are everywhere. They are convenient, cheap, and are used in our everyday life. Plastics have changed the way we live. They have helped improve health care, transport, and food safety. Plastics have allowed many breakthroughs in technologies such as smartphones, computers, and the internet. It is clear that plastics has given our society many benefits, but these benefits have come at a cost. Drawbacks of plastics. Plastics take a very long time to fully break down in nature. The microbes that break down plastic are too few in nature to deal with the quantity of plastics we produce. Some types of plastics contain harmful chemical additives that are not good for human health. Burning of plastics releases toxic gases that are harmful to our health and contribute to climate change. One-time use and throwaway plastics end up littering and polluting the environment. Identifying different types of plastics. The resin codes. Look at the following pictures. One is a plastic sachet in which milk is distributed to consumers, and the other is a plastic food container. Observe the code shown on it, circled. Do you know what this code means? It is called a resin code. The resin code represents the type of polymer used to make plastic. Need for resin codes. Plastic should be recycled or disposed of safely. Certain type of plastics should be avoided so that they do not end up polluting the environment or harming our health. Each plastic is composed of a different polymer or set of molecules. Different molecules do not mix when plastics are recycled. It is like trying to recycle paper and glass together. For this reason, they need to be separated. The resin codes of plastics were designed in 1988 and are a uniform way of classifying the different types of plastic which help recyclers in the sorting process. Find in the resin code on plastic items. The secret resin codes are shown as three chasing arrows in a triangle. There is a number in the middle or letters under the triangle. This is usually difficult to find. It can be found on the label or bottom of a plastic item. The resin codes are numbered from 1 to 7. Resin codes #1 to #6 each identify a certain type of plastic that is often used in products. Resin code #7 is a category which is used for every other plastic since 1988 that does not fit into the category #1 to #6. The resin codes look very similar as the recycling symbol, but this does not mean that all plastics with a code can be recycled. Harmful effects of plastics. Plastics in our everyday life can be harmful for two reasons. The first reason is that some types of plastic contain chemicals that are harmful to our health. The second reason is that a lot of plastics are designed to be used just for one time. This use and throw away plastic causes pollution to our environment. Harmful plastics. There are three types of plastic that use toxic and harmful chemicals. These chemicals are added to plastics to give them certain qualities such as flexibility, strength, color, and fire or UV resistance. The three unsafe plastics are PVC resin coat ash 3, PS resin coat ash 6, also commonly called thermocol, and PC ABS resin coat ash 7. PVC polyvinyl chloride plastics. Heavy metals, cadmium and lead are added to PVC. Burning PVC releases dioxins, one of the most toxic chemicals known to humans. PS polystyrene plastics. Styrene is a building block of this plastic and may cause cancer. It takes very long time to break down, 100 to 1 million years. Higher amounts of toxic styrene leak into our food and drinks when they are hot or oily. PC polycarbonate plastics. PC plastic contains bisphenol A, BPA. BPA leaks out of PC products used for food and drinks. BPA increases or decreases certain hormones and changes the way our bodies work. ABS acrylonitrile butadiene styrene. Styrene causes problems for our eyes, skin, digestive system, and lungs. Brominated flame retardants BFRs are often added. Studies show that toxic chemicals leak from this plastic. One time use plastic. Use and throw away plastics causes short and long term environmental damage. Half of all the plastic made today is used for use and throw away plastic items. These block drains and pollute water bodies. One time use plastic causes health problems for humans, plants, and animals. Some examples of plastic carry bags, cups, plates, straws, water pouches, cutlery, and plastic sheets used for food wrapping. These items take a few seconds to be made in a factory. You will use them for a very short time. Once you throw them away, they can stay in our environment for over 1,000 years, causing plastic pollution for future generations. We need rules and laws to protect people and environment for plastic pollution. New rules to make Tamil Nadu plastic free. As we know, the government of India is progressively taking various legal initiatives to stop plastic pollution by making some provisions and amendments in the Environment Protection Act in 1988. With this reference to this act, Government of Tamil Nadu has taken a step forward to ban the usage of smoke some kind of plastic items. Environment and Forest Department, Tamil Nadu Government number 84, dated 25/6/2018. As per the government order, seated above, the Tamil Nadu government has banned the usage of one time use and throw away plastics from 1st January 2019. This excellent legislation is designed to protect Tamil Nadu from plastic pollution. You can find below some key aspects of the new rules along with science based facts why these items have been banned in Tamil Nadu. Banned items. Plastic carry bags. Globally, we use 2 million plastic bags each minute. 97% of plastic bags do not get recycled. Animals eat plastic bags by accident as they contain food. A cow was found with over 70 kilos of plastic in its stomach. Plastic plates. Dirty plastics like a used plate are difficult to recycle. Most of the one time use plates are made from polystyrene resin called ash 6, which is harmful to our health. Plates will be used for just 20 minutes but stay in the environment for over 1,000 years. Water pouches. Water pouches are often littered, increasing plastic pollution. The blueprint ink on the clear plastic pouch decreases the recycling value. Once a water pouch is used, it is difficult to recycle as it contains leftover water and gets covered in dirt. Plastic straws. Plastic straws are too light and small to be recycled. Straws are one of the top 10 items which are found in the plastic pollution in oceans. 90% of seabirds have ingested plastics such as straws. Plastic sheets. Plastic sheets used on top of plates get dirty and cannot be recycled. More chemicals leak from plastic into food when it is hot, spicy, or oily. Animals such as cows, goats, and dogs eat plastic by accident because it smells like food. Role of students in the prevention of plastic pollution. You play a very important role and have the power to minimize plastic pollution. Ask yourself, is this plastic safe or harmful plastic? If it is not a harmful plastic type, is it a one time use plastic item? These questions and the science based knowledge will help you to reduce unnecessary plastic pollution. What can you do to prevent plastic pollution? As a student, you can share your scientific knowledge on plastics and their effects with your parents, relatives, and friends to make them aware of plastic pollution. You can help by teaching them how to avoid harmful plastics by searching for the resin codes. You can educate them about the new rules and how important it is to stop one time use plastics. Practice in your daily life. Do not litter the environment by throwing plastic items. Do not burn plastics since they release toxic gases that are harmful to our health and contribute to climate change. Segregate your plastic waste and hand this over to the municipal authorities so that it can be recycled. Educate at least one person per day about how to identify the resin codes and avoid unsafe plastics. Resin code ASH 3 PVC, ASH 6 PS, and ASH 7 ABS PC. Thank you, children.